This video will cover number 6 through 9 on the Chapter 5 test review. These problems are all about using our special types of triangles, such as equilateral triangles and isosceles triangles, to solve problems. Number 6, find the value of x, AB, BC, and AC if triangle ABC is equilateral. So we know the triangle is equilateral, not only because it tells us in the word problem, in the sentence, but because it gives each side one tick mark, meaning that all sides are congruent. So to find x, I need to set up a true equation. Now what I notice is x is a variable that's on each of the lengths of the equilateral triangle. So I want to ask myself, what do I know about the lengths of an equilateral triangle? They are all the same. So to set up my equation, I really just need 2 of these lengths. I can choose any 2 that I would like, and I just need to set them equal to each other. So 3x plus 12, that side length must be equal to 6x. I'm going to go ahead and solve this for x. And I discover that x is equal to 4. So now to find the actual lengths of these sides, I could go and plug 4 in for x. So to find the length of BC, I would just need to calculate 6 times 4, which is 24. Now, I don't technically need to go ahead and plug 4 in for x on the other 2 sides, because if this is an equilateral triangle, if BC has a length of 24, then line segment AB and AC should also have a length of 24. Number 7, find the value of x. This time, I notice I still have an equilateral triangle. But notice x this time is not on a side, it is in angle measures. So now I have to think about, what do I know about the angles inside an equilateral triangle? Well, we know that all the angles in an equilateral triangle are congruent. They are equal to each other. So one way I could solve this problem is I could take 2 of the angles and set them equal to each other. So you could do this. You could set, for example, 21x minus 3 equals 17x plus 9, and you could solve for x. Another way that I think is just a little bit quicker is we learned that in an equilateral triangle, all the angles must have a measure of 60 degrees. And so another equation you could have set up is by setting one of these angles equal to 60 degrees. 21x minus 3, I know, has to be equal to 60 degrees. Either method should get you the same answer for x. I'm just going to go ahead and solve this one on the right because it's a little bit quicker. I'm going to add 3 to both sides. And then I'm going to divide both sides by 21. And I get that x is equal to 3. Number 8, suppose triangle JKM is isosceles with vertex angle K. Let's go ahead and draw a picture of this particular triangle. I'm going to draw an isosceles triangle. So I'm going to let these 2 sides of my isosceles triangle be the legs that are congruent, which means these 2 angles are my congruent base angles. Now, angle K is the vertex angle. This angle is my vertex angle. It's the angle that is not one of the base angles. And so I'm just going to go ahead and label my triangle like this. K has to be on the vertex angle. So now I have some information here. They tell me the measure of angle J is 8x minus 5. And the measure of angle M is 3x plus 25. Find the measure of angle K. Before I can find the measure of angle K, I have to find the value of x. And so I need to set up an equation. I notice the two angles that have an x in it are my base angles of my isosceles triangle. We know the base angles always need to be congruent or equal. So to set up my equation, I know the measure of angle J, which is 8x minus 5, must be equal to the measure of angle M, which is 3x plus 25. I'm going to go ahead and solve this. After I divide both sides by 5, I get that x is equal to 6. Now remember, I want to find the measure of angle K. So first, I need to take my x value and plug it in to get the measure of angle J and angle M. When I plug in 6 for x, 8 times 6 minus 5 is 43. This angle must also be 43 degrees since they are congruent. So to find the measure of angle K, since 3 angles in a triangle must add up to 180, to find that last angle, I can take the total, 180, and subtract my 2 angles that I do know. 180 minus 43 is 94 degrees. So the measure of angle K is 94 degrees. All right, the last one. Suppose that line segment AB is congruent to line segment DB. I'm going to go ahead and mark that in my picture. And line segment CD is congruent to line segment BD. Notice I've already given one tick mark to line segment BD. So if line segment CD is congruent to line segment BD, I should also give line segment CD one tick mark. This tells me that all 3 of these line segments are congruent to each other. Angle A is 31 degrees. I need to find the measure of angle BDC. That is this angle here. So looking at my picture, I notice I have 2 different isosceles triangles. I have one here on the left and one here on the right. I'm first going to be working with this isosceles triangle since I know one of the angle measures in this triangle. If I think about my angles in this isosceles triangle, if these are the 2 congruent legs, this is the base, meaning angle A and angle ADB must be the congruent base angles. So if angle A is 31 degrees, the measure of angle ADB is also 31 degrees. Now I need to try to somehow figure out what the angles in this triangle are. And what I notice is if I find this angle here, I can use this one to help me find this angle in triangle BCD. So let's go ahead and find this angle. I know these 2 angles in the triangle. To get that third one, remember I can take the 2 angles I know and subtract them from 180. When I do that, this angle here is 118 degrees. So now I want to work on finding the angles in this isosceles triangle. I notice that these 2 angles make a straight line, angle ABD and angle CBD. If this angle is 118, it must add with this one to make 180 degrees. So if I take 180 degrees and I subtract 118, I see that this angle here is 62 degrees. So remember, this triangle is also isosceles. If these two sides are the congruent legs, this side is my base, which tells me that this angle and this angle are my congruent base angles. So if angle CBD has a measure of 62 degrees, angle C also has a measure of 62 degrees. So finally, to find my last missing angle inside this triangle, since it's the third angle that I don't know, I can take 180 degrees and subtract these two interior angles to find the measure of that last interior angle. When I do that, I discover that the measure of angle BDC is 56 degrees.